In this video, I'd like to talk about word problems with right triangle trigonometry. So let's just start with some examples. We're going to look at three different problems and we'll work out a strategy as we go. So let's just jump right into this problem. The people of Bridgetown wanted to build a bridge across a nearby river. Since they were poor swimmers, their master Trigonomus agreed to measure the width of the river without actually crossing it. So it looks like we're measuring how wide the river is. So Trigonomus spotted a tree across the river and marked the spot directly across from it. That's right here and here. Then he walked to another point 15 meters down the river and found that the angle between his side of the river and the line connecting him to the tree was 76 degrees. So he walked to the left here, found this point, and then measured the angle there. And you can measure that in various ways, but maybe he just had a protractor and measured 76 degrees. And from this information, we can figure out what the width of that river is. And then we'll need to route our answer. So let's start by defining a variable. We'll say that W is the width of the river. And we'll need to mark that on our drawing. So that can go right there. And at this point, we'll need to use trigonometry since we have an angle and a missing side length, and we know another side length. So when using trigonometry, remember it's helpful to write SOHCAHTOA so that you can remember all the definitions. And we have this angle here, 76 degrees, and we know the side length that's across from it. Remember, that is our opposite side. And we know the side length next to it. Remember, that's what we call the adjacent side. Whereas the long side of the triangle, that's always the hypotenuse. So we're looking for a trigonometric ratio here, either sine, cosine, or tangent, that involves the opposite and the adjacent side. So you might notice that is our tangent function. Since in general, the tangent of some angle, we'll call it theta, is equal to the ratio of the opposite side divided by the adjacent side. So we can set up our relationship here by plugging in our specific numbers and our variable w. So we can say that the tangent of our angle, it's 76 degrees, and this is equal to the opposite side, which is w, that's the thing we're trying to find, divided by the adjacent side, which we know is 15. And at this point, we just have an equation involving w that we can solve for. And remember that the tangent of some known angle, this is just a number. And so when solving this equation, let's first get w by itself. So we can multiply each side by 15. Let me make just a bit more room here. So multiplying each side of the equation by 15 will allow these to cancel out. And so that w is just 15 times the tangent of 76 degrees. Now, to evaluate this, we're going to need a calculator. So let's get out our graphing calculator. And we're looking at 15 times the tangent of 76. So we write 15, let me erase that, 15 times the tangent of 76. Now, before we put in the answer, one common mistake with trigonometry is that students are in the wrong mode. So we want to go to mode first, and then go down to the fourth row here, where it says radian and degree. Now, our answer is in degrees, not radians. Radians usually involve pi, but they don't always have to. So make sure if you're using degrees that you're in the right mode, otherwise you're going to get a completely wrong answer. So we type that in and we get 60.16 since we need to round to the nearest hundredth. So W, let me use a different color, W is 60.16 meters. And so that's what we would put into the box here. And this should make some intuitive sense since not counting the right angle, this is the biggest angle in the triangle. So it's the second biggest out of the three. And if you wanted, you could figure out that this is 14 degrees by subtracting this and your right angle 90 degrees from 180 to find this missing angle, or we know that in a right triangle, the two acute angles are complementary, they add up to 90, and the bigger angle opens to the bigger side. And since 76 is significantly bigger than 14, we would expect our width to be significantly bigger than 15, which it is. But it will still be smaller than the hypotenuse, since that is across from the biggest angle, the 90-degree angle. The hypotenuse is always the biggest side. So, with that in mind, that just gives you a rough idea to check that you're on the right path. If we got a number smaller than 15 or even close to 15, we would know that there was probably a mistake there. So let's move on. We'll try a couple more of these problems.